scientists like Augustin Jean Fresnel and George Stokes proposed alternative solutions to the reason why the speed of light did not seem to be affected by the ether. They assumed that there existed some form of ether drag, where the ether is dragged by the friction of the Earth when it is near the Earth, and has less or no drag in deep space. To understand this, let us return to the umbrella analogy. If the rain is falling straight down, and you are walking perpendicular to the falling rain, the rain would appear to be falling towards you at an angle. The ether dragging hypothesis would be analogous to the idea that as you walk, the air around you is dragged around you, such that when the rain gets close to you, it gets trapped in your local ether and is pushed by your ether wind. This explanation covers why Bradley may have had to tilt his telescope. If the ether is stationary and doesn't ever move, then the motion of the Earth should cause relativity effects, making the light appear to move at an angle as you move perpendicular to it, and straight down as you move parallel to it. However, this at all does not explain how the speed of light appeared to be constant. Thomas Young, in 1804, was one of the scientists that reasoned that light was a wave, and not a corpuscular as Bradley believed, and that the ether was immobile in the frame of reference of the sun, and that the Earth had no effect on the ether. But he could not explain the aberration effect. However, Young was able to show that light is a wave in other experiments. His most famous experiment was the double slit experiment. If light was a wave like sound or water as they expected, then there ought to be an interference pattern when light moves past and through an object in its path. In the same way that a water wavefront hitting a double slit will cause there to be two circular wavefronts, so should light if it is a wave. Young demonstrated in 1803 that by shining a light through the double slit, there was in fact an interference pattern at the screen. Young also knew that light had to be a wave in order to explain why light reflects and refracts at the same time. If light was a single ball, then it could not do both at once. However, Newton had already demonstrated that the ether, which is what would be waving, cannot be doing so longitudinally, as this would cause the disturbance of the motions of the planets and would cause lighting effects that we do not observe. So it was, at the turn of the 19th century, that light had to be a wave. That wave had to be a wave in something, and that something cannot be a wave like sound. Also, light would have to behave like a particle sometimes. The ether would have to have been densely packed, but rare, transparent, fluid, but sometimes solid, frictionless, and also maybe having ether friction drag. The particle theorists at this time attacked Young in his inability to mathematically describe the interference pattern of the waves of light. They thought that they could explain diffraction with the idea that beads of light bounce off of each other and cancel. The particle theorists thought that they could finally kill the wave theory of light by holding a science contest on diffraction in 1818 at the Academy of Science. The winner of this contest would thus put an end to one of the two theories. Either the particle theory or the wave theory was going to emerge the sole victor. The winner of this contest was Augustin Jean Fresnel, whose paper supported the wave theory of light. Fresnel, without knowing much or anything at all about Huygens and Young, had already integrated their two theories into his own original work. Young, discovering Fresnel, suggested that Fresnel submit his paper to the Academy. Fresnel's idea could explain reflection, refraction, diffraction, and polarization, covering all of the topics that had been fought over for the last 200 years or more. One of the judges of the contest, Simon Denis Poisson, who was a particle theorist, thought that Fresnel's paper had a big issue. That being that the center of a circular shadow would have to have a constructive interference pattern, thus having a bright light spot in the center of a shadow which he thought was ridiculous. One of the other judges and the head of the committee, Dominique Francois Jean Argot, took up the challenge on behalf of Fresnel and proved that the bright light spot does in fact exist as Poisson predicted. This was the end of the particle theory of light. The only thing that was an issue for the wave theory in the past was the longitudinal nature of the waves, but Fresnel ended that issue by proving that light is a transverse wave, not a longitudinal wave. This had a whole new effect on the theory of ether, as transverse waves cannot travel in fluids, but only in solids. It seems then at odds that the ether had to be a solid to allow light to travel, and yet it had to be a solid that doesn't affect the motions of planetary bodies, therefore returning us back to the issue of ether drag. Fresnel in 1830 came up with the math that would be used for predicting and measuring the ether drag by massive objects. For the next 50 years, the scientists battled it out over whether ether drag was occurring or not. In 1851, Armand Fizeau conducted an experiment with the first interferometer. He believed that the light will be dragged around by a medium, and so he uses columns of water flowing in different directions. Fizeau believed that his experiment demonstrated a partial ether drag, but his results were a lot lower than he had expected. A follow-up experiment by Hoek demonstrated that there was no dragging effect, and Hoek could not figure out why his version of Fizeau's experiment failed. In 1871, George Airy conducts an experiment as laid out by Young in 1804, using stellar aberration and a water-filled telescope. Airy concludes that the stellar aberration remains, and the ether drag could not be measured. In 1881 and 1887, Michelson, and later Michelson and his partner Morley, conduct the most famous ether dragging experiment, the Michelson-Morley interferometer experiment. The Michelson-Morley interferometer experiment found that light appears to move through the ether at the same velocity in every direction, no matter where the Earth is in its orbit, and no matter which way they rotated the experimental apparatus. This is where the conclusion that the ether doesn't exist comes from. But this experiment cannot disprove an ether, something that has to occupy space. This experiment merely showed that the ether was not being dragged. It proves that the luminiferous ether doesn't exist. That light doesn't need a material substance called a medium, like air, water, or glass, in order to travel. It proves that the little stuff, which exists where nothing isn't, is not a particulate matter. This video is possible thanks to contributions to the Existence University Patreon by viewers like you. Thank you.